Hi everyone, myself Palak Agarwal and I'll be going to teach you chapter first of the 9th class number system. So are you excited to learn from me? Hope you are. So just we would start with number system. First of all, tell me what are numbers. It's a basic unit in mathematics which generally gives us different operations. Like it's an object. You could say if digits weren't there, would be able to multiplication, subtraction, addition, these operations we won't be able to use, right? So numbers are the basic unit of mathematics according to me. Okay, next. Now, to understand number is in a better way, we are going to develop a system for that. And for which we need to know what are different types of number. So the first number type which comes is natural numbers. Any number starting from 1 to infinity are natural numbers and they are denoted by capital N. Just remember the denotation part, since in the questions they don't usually write natural numbers, they write capital N. You need to get it like it's a natural number. Okay. Next is whole number. Any number starting from 0 to infinity, including 0 obviously, are whole numbers and they are denoted by capital W. Next is integers. Negative, positive and including 0 are integers. This is the simplest definition you could get and it's denoted by capital Z. Okay. Next is, since we have learned three types of number, what are they? Natural numbers, whole numbers and integers. And all these numbers including other form of numbers, suppose 1 by 3, 1 by 4, 1 by 2 are rational numbers. Okay. So rational numbers are generally denoted by Q. And rational numbers definition says that it can be written in the form of P by Q where Q is not equal to 0. Okay. So Q can't be 0 since any number divided by 0 or when the denominator is 0, we say that the number is undefined. So undefined number can't be in a type of numbers. So therefore we simply state the condition that Q should be equal to 0. Okay. Maths are all about facts. Okay. You don't need to grasp the definition. You just need to focus on why it's saying so. Okay. Let's just do a simple question and see if you are able to do it or not. Okay. There are statements given. You need to find out whether it's true or false. Just read the first statement. Every whole number is a natural number. Is it true or false? Think about it. Okay, so I have written true. Why is it so? What are whole numbers? Whole numbers are numbers which starts from 0. Okay, and natural numbers are numbers which starts from 1. So can you think of a whole number which is not a natural number? I can think of 0. Oh, blunder. It wasn't true, it was false. Okay, so what strategy should we follow? We should always think of example which contradict our statement. Okay, so in that way you could arrive at a correct solution. Let's try again. Okay, every integer is a rational number. What are integers? Positive, negative and 0. What are rational numbers? P by Q form. Okay, can we write any number divided by 1? Obviously we can write. So yeah, we can say that integers are rational numbers. You can't think of a single number which confides the definition of rational numbers, right? Okay. Every rational number is an integer. Oh, I have plenty of examples which are not integer but rational numbers. This all are rational numbers, but they are not integers. So this is false. Okay. Next, we would go to another question. Okay. So, give 5 rational numbers between 1 and 2. Rational numbers. Simply P by Q form 1 and 2. Okay. So, the number which we're gonna give, let's just denote by N, should be between 1 and 2. Okay. So, just keep on writing 1 by. Okay, no. So, that should be in between 1 and 2. Okay. So there's a simple formula to solve this question. Just add the two numbers in the range and divide it by a bigger number. Okay, so see here. 1 and 2. A plus B divide by 2, which will give me 3 by 2. Okay, correct? And just keep on dividing it with a number in between. Okay, so in this way, you can find 5 rational numbers between two numbers. Okay. Okay, so now let's just keep on segregating. Okay, this method which I'm using, you would be using the same. So first number we got 3 by 2. Now again, Suppose A is 1 this time and B would be 3 by 2 since it's a number in between. So divide by 2. It would be 5 by 4. Okay, so that's the next number. Now you keep on doing the same thing. Okay, so it will be 9 by 8. Again we could do the same thing. Okay, you could ask me one question like, ma'am, couldn't we use 3 by 2 and 2? Obviously you can do. I'll just show you one example. Okay, this would be 17 by 16 and see 3 by 2 plus 2 by 2, 7 by 4. Okay, so in this way you will find. So I hope you're clear. What I did was I took the A and B and just keep on dividing it by 2. So next B would be the between one or next A would be the between one. It depends on you. Okay, so in this way you would get the 5 numbers. Now, rational numbers between any two given numbers. So we can say that there are infinitely many numbers between any two rational numbers. Okay, so in previous example we saw what I am saying now. Like from previous example it can't be proved, right? We get multiple A and B, and for every A, B there will be a midpoint. Okay, and every rational number exists between 2 points. So there are infinitely many numbers. Now, the next type of numbers which we are going to learn about is irrational numbers. So what are irrational numbers? You learned about rational numbers. Now we are going to see what are irrational numbers and how they are defined. Okay, so any number which is irrational cannot be defined in the form of P by Q, and same definition, P and Q are integers and Q is not equal to 0. So all the rational numbers are those numbers which can't be defined P by Q form and Q is not equal to 0. Okay, so there is a bigger picture. We know real numbers, right? Every number. So real number minus rational number would be considered irrational. Simple. Okay, so any number which can't be in the form of P by Q or can't be a rational number is a irrational number. So example is given in front of you like root 2, root 3, root 15, even pi. You might have heard about pi, right? We use it for the circumference of a circle. Yeah, same pi. Okay, next. Okay, real numbers I just told you previously. So real number is a collection of rational numbers and irrational number together. They make up collection real numbers and they are denoted by capital R. So they call number line a real number line because number line shows every number. Okay, so every number is collection of all the numbers and what we call it real numbers. So number line is also known as real number line. And there are some numbers which can't be shown, like how to locate irrational numbers. Suppose I tell you draw a line and simply locate 1, 2 and 3. You would do that. Okay, let's make it a little harder. I'll give you a rational number half. You would simply say keep 0 and 1 and the midpoint is half. You can do that too. You'll just segment or divide the line in smaller portions, right? What if I told you to draw a irrational? Rational numbers are easy, but what if I told you to draw irrational number? Suppose root 2. What you are gonna do? See here carefully. So O to A is 1, and we have drawn a square of side 1. From square, you know, right? All sides are equal. So we have done a square of root of one side. Now we're gonna just keep a diagonal from O to B. And just tell me, you know the hypotenuse rule, right? A right angle triangle, you know, like it says that height and perpendicular square sum is equal to the hypotenuse square, right? So according to that formula, we derive at a conclusion that 1 square plus 1 square is 2 square and 2. Okay, 1 square plus 1 square is 2. And 2 is equal to hypotenuse square, which say that OB is equal to root 2. So in this way, we have drawn root 2. Now, how to plot it in the graph? Just take your arc, keep it on OB and drag it till the number line. And you would get O to P. And O to P denotes root 2 value. Okay. So in this way, we define root 2. Or we show root 2 or any irrational number in number line. Now, what about root 3? Just think of a simple rule, hypotenuse rule I told you earlier. Now, root 2 square is 2 and we need to add 1 to it in order to make it root 3, right? So, we'll just again draw a perpendicular to OB of 1, okay? And we'll just connect OD, just look at here. And OD would be root 3. And we'll just again do the same process, drag your arc and drag it to the number line, and you would arrive at a point called Q, and O to Q would be showing root